I'm Kristo. I work as head of architecture in Pipedrive, and so why I talk about the pains and gains of microservices is because, yeah, I think it was like 1.5 years ago or 2 years ago, we kind of went on a journey in the sense that we kind of did not entirely know where we end up, but we thought it's a good idea to do this. So today's talk is mostly about just like sharing the experiences that we had, like what did we kind of do well, what we didn't do well, like what to learn. It's mostly about sharing, like, and just, I guess, finding the niche, if this is for you, if this makes sense for you, and if you should do it or not. So a bit about my background. So I've been working in kind of, I would say, fast-growing startups for most of my life. Spent 8 years in Skype, started as database. I even don't remember what I started from, but at some point I became a database administrator, then database developer, then was leading the database development team, then 2 years of Skype to Go product engineering, which kind of was also like, why it's relevant actually is that we have, I think, like 150, 200 different tiny scripts that were running and doing something in the system. So in some sense you might say these are microservices, in some sense you might not, and I'll get back to it later. And Skype to Go, in that sense, it was also about kind of separating one product from the rest of it. So it's controlled, it's just one team that manages it. And yeah, the last 3 years in Pipedrive have been quite right, and I would say like 2 of it was again like trying to figure out how to like better optimize for the services, like how to create this pattern that would work and what the benefits are. So that's why I mentioned the background. So it's why the microservices are like question marks is because everybody has a bit of a different opinion what a microservice is, and it's really hard to define. So everybody has a bit of a different definition. I'm not going deeply into it. We thought we were doing microservices in Skype, but right now I'm not saying that it's entirely a lie, but in some sense it is. So, but before getting to microservices, let's talk about Pipedrive and growth. So I don't know how many of you know what we do or who we are, but in the end we build a sales CRM, and it's meant for complex sales. So it's not cold calling when you get again a call if you want to buy Äripäev or whatever it's the journals are, but it's most about these long and complex sales processes. And why it's relevant also is that this means that we have quite a bit of relatively complex business logic that is all quite tightly right now bound together. Typical startup life, you know. Everybody starts writing code, it gets more complex, then you end up with something that is kind of huge and hard to understand. And this is normal for a startup. If you don't end up like this, then you're probably over-optimized at the wrong stages. It's quite normal in that sense. And we have over 50,000 paying customers from 155 countries. 250 people, it's growing so fast. And mainly the amount of people that is constantly like joining us is the main reason why I talk about microservices. And 20 different nationalities, so quite a mixed crowd. And yeah, in the last 4 years, we've gone from 10 to 100 engineers. Not all of them are developers, but so of course like supporting functions all around it. From 5,000 to 50,000 customers, and from 2,000 to over 200 components. And by component is like libraries, deployable pieces, so tons of tiny things that all need to interconnect with each other in one or another way.
Microservices.
Not only. And so this is still far from the microservices, but it's just like how it works in typical startup. You have your different phases where you need to focus on different areas. Like first of all, just to try to prove that you're worthy of your idea is worthy of being something great in the future, up to the point where you just like need to pour all of the resources in to get you growing as fast as possible. And typically, like when you scale the system, there's like standard patterns that you use, and all of these work. And none of these, in some sense, really require you to do microservices. This isn't even related. So when you are in a really early stage, you grow with just taking bigger boxes. So even like it was really complicated some years ago. Now it's really easy. You take a bigger AWS instance, and voila, you are there. And at that point, it's the right thing to do. You shouldn't worry about like what goes on, how do I shard, what do I do. Just like find the people who pay you money and don't worry about it. Don't over optimize in the beginning. It's waste. The next stage, when you actually have already like customers coming, you need to plan ahead. You need to worry about it. You need to add more hardware instances. And by adding hardware instances, it's not only sharding, it's also like bringing the load to background processing. So you answer as quickly as possible, then you take the like massive load to the background. And this also goes into that phase. Where we are right now is the third stage, which is like scale side by side with more systems. So besides the journey with microservices, one of the biggest adventures has been actually going multi-regional. So having our product set up in a way that we can have customers in data centers completely like that are quite far apart, like Europe and US, and making this all working seamlessly together. So it's basically because when you build a system, then you never know like when things are going to break. But when you build a similar system next to it, then you're quite sure that up to this point it's not breaking. You know already like how much it can take, and if you build more systems, then you don't need to worry about things breaking at random points. And yeah, growth is actually a nice problem to have, to be honest. It's worse if you don't have it. But when you have a lot of growth, then the main focus in engineering, as it should be, is not becoming a bottleneck. And it kind of leads to the talk, finally, I promise. In order to not become a bottleneck, you need to predict the future. And there's like really obvious things, and there's things that are not very obvious. The obvious things is like architectural. You have some system that scales up to some certain point. You scale it out, you figure out how to do the sharding. It's obvious to hire good people. That's something that you should do from day one and continue doing until very late. Like forever, sorry, not very late. And grow. Always find some new challenges and go with the flow. However, there's hidden bottlenecks, which is like quality, process, organization. And this is where actually the whole microservice world will come in, because if you scale with the way that I just mentioned, sharding for more hardware, building systems side by side, you will still not eliminate the like most painful bit about it. It's about the amount of people that constantly get added to your organization and how they actually manage to work together without causing a lot of stepping on each other's toes. So these are actually the questions like what you should ask for in order to like, does it trigger anything? Like how many merge conflicts did you solve in the past month? Raise your hands, fingers. 1. I think everybody's lucky. I don't know what you're doing. 2, 5. It's growing. So if a bug happens, how quickly usually you can find a team who will fix it? I don't know how many. Do you have one team? Yeah, then it's easy. But so these questions that I wrote here, these are mostly the things that, like, when these questions start to play in your mind, then this might be the right idea to think about microservices. And so let's get to the point now. What are microservices? It's, as I said, it's the question marks, not question marks, but the apostrophes around it. They were there for a reason. And why they are there is that everybody has some microservices. Usually if you do like image resizing, it's a microservice. Like hell, it's separately deployable, it's a microservice, it works. So when I talk about these microservices, I'm not talking about you having a message broker and you building a script that consumes the events from there, doing some rendering, doing some actions. These are microservices. I'm not like saying they are not, but today I'm going to talk about just like consciously applying the pattern, and this is what this talk is all about. So from at least one of the definitions, one of the main goals of the microservice architecture is to accelerate the software development by having a really kind of fluid system to develop, deploy, and continuously do it on a daily basis. So this slide I stole from Microservices.io, which is a great resource, by the way. I'll come back to it a bit later. And the whole kind of ideology behind it is that when you do the microservice architecture, the main reason for it should be in order to enable continuous delivery and deployment. If you do deployments like every 2 weeks, then yeah, you can have the microservice, but do you really even need it? Like there's of course like benefits to it. Why we do it is I guess for a couple of reasons. First of all, like doing continuous deployment. Secondly, also having teams that don't step on each other's toes. Well, that's at least what we set out to do when we went on this journey. And usually with the microservices, it's also that they should have a limited impact. So they shouldn't create the butterfly effect. If you change something in the system, it should be encapsulated into the closest like area that is possible. It shouldn't go around the system. It's so common that you change something in the core and something completely in the other side of the system breaks, and then you start building all of the unit tests to make sure that this doesn't happen. So a good example from our own kind of journey is statistics. So you have all of this complex system and you create data there, but once you create the microservice that is just for the statistics that reads it, then how do you guarantee that the system doesn't like constantly break? And why it breaks is that it is not in some sense a proper microservice. It doesn't really encapsulate all of the data that is needed. If it would be mutable data coming from the original data store, then yes, it could be built as a proper microservice. But on the other side, right now, in the definition of coupling, it's not really a good example of a microservice. So why we came to the point where we even looked at the microservices is mostly because of how we have worked and wanted to continue working. So in Pipedrive, the teams work as tiny startups. So we want them to be completely self-sufficient, not to have too many steps where you need to kind of take and throw the things over the wall. And by taking and throwing things over the wall, there's tons of different things. But I think that's the next slide. Yeah, I'm going to get there. But we do 1 week sprints. We did 2 week sprints. But moving from this 2 week to 1 week sprints, it was, I think, the biggest riot that we've had. Yeah, it's like if it hurts, do it more often. Our definition of done is that everything is in live. This means that we have accustomed to doing lots of deployments on a daily basis. So once you finish a task, it goes to live. We don't pile them up and do weekly releases. We usually, every single feature, we put them quite soon to live, even before it's MVP, just to test it out. And this means that there's no long-lived branches. So everything is already in live, but it's enabled only when you have a feature flag set for that specific user or company, actually. And yeah, what we don't have is product demos, because the product owner is sitting next to the team. So we are doing kind of typical Scrum, but we have cut the corners where they didn't make sense anymore. And we don't have QA, so everybody's writing their own tests. So why we work like this? is for minimizing the amount of handover. It's usually like, yeah, I write the code, I throw it to QA, the QA tests it, they say, nah, no, you need to do this and you need to do that. And all of this is communication that in some sense you don't really need. It's, of course it provides value. I can't say that QA, like manual testing or this kind of reviews don't provide value, but they create quite a lot of ping pong in the process. They create a lot of waste. And if you do changes that are small, you do them often, if it hurts, then in the end, if you do it a lot, you will end up with a kind of better result than constantly having these waterfall-like steps where it gets thrown over the wall. And yeah, of course we do tons of code review, and yeah, you might ask like, what does QE do in our context? So they do provide a lot of tooling, they take care of the build systems, they provide like, let's say, Sonar Cube that does the static code analysis, all of these kind of things, and they help you out, of course, when you need to create a test plan, do things like that. But they are not actively involved in the development. If you have some kind of test that is failing, then they will tell you that the test is failing. They don't know really what the context of the test is, or like how it works, or what systems does it touch. And maybe it sounds a bit strange, but it has worked quite well for us. And yeah, this works nicely if you have one team, 2 teams, up to even 3 teams. But as I mentioned, with the amount of growth that we've had, it kind of became obvious that once we grow from like 3 teams to maybe 10, this won't work anymore. It just like can't work. So I guess the old and stupid saying is you can't make a baby with 9 women in 1 month, because it's just like all of these developers won't fit on the same code base. So that was the main concern when we went down the path to chase the microservices. And yeah, there's like other ways that, I don't know, in Pipedrive we have a lot of people who come from different backgrounds as well, and they might have heard the horrendous term called change advisor board. So this is basically because when you break tons of things, you will get really scared of doing this, and you will ask the highest people in the company to sit down with you like once a month, and then you need to show all of the papers that yes, I have tested it, and yes, I know this does this and this does that, and then you get an approval that you can put it to live. You do it like every month or every week or whatever. It fails, you roll it back, then all of the company needs to readjust because they are depending on you. So yes, it works. I mean, you will have less failures, but in the long term, yeah, it has its like kind of benefits because it's easy to refactor things. If you don't release anything in 2 months, of course it's easy to refactor. I have 2 months to rewrite everything. And there's some kind of small benefits, but does it fix anything? Yep. But no, still, no. And the issue with it is actually the same thing, like because you have so much time, the teams go on like 2 weeks, 6 months, whatever, refactoring trips. Oh, this is bad, I'm gonna refactor all of the core. Then like 4 weeks in, they decide that, oh, hell yeah, you know, this we didn't consider, we need to do this and that. I've seen like months and months of work being rolled back. And if you do things like that, then I think it's kind of time to sit down and reconsider, like, if this is actually like the best practice that you are chasing, or does it make even sense? And with long-lived branches, it will be guaranteed that you will have merge conflicts. If we compare it with the way how we work, it's like we do stuff, it gets released in usually like 3 days. So that's kind of a reasonable amount of code that you write. And if you do it for 1 month, because yeah, you have time for the release, it will end up in some kind of merge conflict. And man, do I hate merge conflicts. I'm the worst resolver of merge conflicts. Not even in the biggest companies, but what I've seen is like dependency management in Scrum of Scrums. So you basically sit down for one whole hour and you decide like whose stuff will need to be released first, so you can use that part in order to deliver that part, so the next team can take it over and continue from that. Yeah, random regressions, seen it, been there. Something gets changed in the core and everything explodes. If you have, instead of 10 people, like 100 people changing something in the core, it will happen quite often. And if you have one system, then it's kind of easy that something breaks and nobody knows who actually should fix it. So there's a lot of ping pong in finding just the owner who needs to touch it. So yeah, I actually did part of this talk in Lisbon, and this is like what release management in Lisbon looks like. I think this is my hobbit hole, and they were honking for 20 minutes because one car wanted to get out. So this is the big corporate way of doing release management. And yeah, so let's talk a bit about the system. And 1.5 years ago, it's kind of easy. There's the big elephant, which is all of the core that we have written. Or front is a single page app in Backbone. There's, each customer has their own database, so no issues with sharding. We've kind of done well in that sense. Usually something happens in the app, you push it to RabbitMQ, and some of these asynchronous microservices or scripts, or however we call them, pick them up and do something and put it back to the API. And the solution to growth that we took, just because we know that we knew that the amount of people that we hire will be so huge that when we put them all together working on that elephant, everything will break, was something that I just discovered from the latest ThoughtWorks Technology Radar. I didn't know the term. We didn't have the term, at least in ThoughtWorks Technology Radar 1.5 years ago. It's legacy in a box. So the idea about it is that our API is really solid. It kind of works. It almost never changes because we don't have versioning. It can't really change. You might just break it. So we took that API, or like this core product that we have, and we left it as it is. And we found ways how to do stuff around it, because we are hiring a lot of people. We have so many ideas. We have so many things to do. And in order to create room, the space for them to work somewhere, you need to not put them all together in one place. And yeah, that's the approach we took. Our stack is, I don't know, it's kind of traditional, maybe not that. Consul, Docker, Swarm, Jenkins, and a bit of magic here and there. And yes, we didn't take Kubernetes because at that time looked a bit dangerous. It's good when you start from scratch, but most of our services were not Dockerized. Or, it would have been quite a lot more work doing it this way. So right now I might reconsider, but that's the reasoning why we took the tech stack. And the first things that we started with is a couple of features in the product. Like we refactored import, which is a completely separate service. So the UI gets loaded from the microservice. It has its own API. And basically, you upload an Excel, then it calls all of the existing API methods, and slowly but steadily uploads it to the system. Second one was Pipedrive web forms, which enables you to kind of put the form on your page where people can enter data, and this will end up as a deal in the pipeline. And these were the first kind of piloting microservices, and it worked. There was a huge mess in the beginning. But yeah, we were doing too many things at the same time. And I'll get to all of the list of things that we were trying to achieve at the same time, but it coincided also with us trying to do this system side by side, which is like a huge task on its own. But it worked, and why it worked, or like how do we measure that it worked? It's basically this. This is from a couple of, at least a month or 2 months ago, but this kind of shows where we are right now. There's the big day that I'm talking about. We did like 40 deployments, and this is for I think 15 teams. Yeah, right now the the moment when I wrote these slides, this was 13, so I constantly need to check the numbers. And in average, by now, it does something like around 3 releases per day per team. And these are live releases. And this is our test environment, color boxes. I don't know what the hell they did here, but this is not normal, I guess. I guess they were just testing how much it can take. But the usual number seems to be around 200 on a busy day. So, like, now looking back at all that we did, the benefits are kind of clear. This is what we wanted to achieve. We deliver pretty much at the rate that we are used to. Of course, there's like overhead because we had to implement tons of things, but in the end, like, our effort was concentrated about keeping the development pipeline like working, not to have too many conflicts, and keep on delivering at the rate that we are used to. So the funny thing is that once we started moving things out, now there's only like 2 or 3 teams actually working on the core, like doing stuff there regularly. And once you kind of move out, it is a bit of a surprise, because everybody said like, no, we need to constantly do and change something in the core. Yes, they do, but it's usually tiny changes, and these are relatively isolated, and there's no big things happening there. There might come some big changes, of course, but during the past, I think 1.5 years, then there was no big massive refactorings done there. So it's kind of, if you have the core and it's easy to write code there, then everybody writes there. But if you kind of prohibit doing it, they will find a way. That's how developers work. The cool thing, however, is we have the 15 teams and we don't have a Scrum of Scrums meeting. Because the teams are so independent that there's not too much to share. We have some weekly like engineering meetings where everybody is talking about what they are going to do and what's happening. But there's no dependency management meeting as such. We do have a separate meeting to collect all of the impediments that the teams have in Scrum and analyze them, all of the incidents that they have. But these are called architecture meetings, and the focus of these is to improve on the process and where we went wrong and stuff like that. But we really don't have anything for dependency management. Yeah. And things that magically happened. There's great test coverage on new components, because if you've, I don't know, I've tried to write unit tests on Ruby on Rails Active Directory. It was hell. So when you create the services, you know that they, like, it's kind of a drawback of what one of the cons. I didn't mention it, but I think the con doesn't come yet. Yep. Yes, it's one of the things is that the testing doesn't work the same way as it used to. So we can't have all of the things, because when 15 teams are separately deploying, then it's really crazy to have a fully like functioning UI test all around the place. So people need to find different ways how to test, and all of the new components, because they don't have any big kind of technical depth yet. They're really easy to make them testable. So the new node services, they are like 80, 90, whatever, 100% coverage. They even managed to get it to those numbers now with front end. And this is like unit test branch coverage that I'm talking about. Merge conflicts. I was asking around when people started complaining how long the delays in the deployment system are, and everybody said, hell yeah, I can't remember like when we had a merge conflict, and that's one of the like really big benefits. Clear ownership, like when you find a bug, if you see that import service has crashed, then it's kind of clear that this is the team that handles the import service that needs to fix it. And it's easy to refactor, and why I'm saying it is that in the end, like, yeah, you can refactor everything. It's more convenient to refactor the monolith. But the thing is that whatever code you write, 5 years in the future, you will look back at it and you think it's complete crap. And it's better to have 10 tiny craps instead of 1 big crap. Because it's kind of manageable. You take your 2 weeks, you refactor it. Even if you like want to switch out and instead of Node start doing Go, you have the option. If you have 1 big core, you will be stuck with it forever and forever. So, sorry. As for benefits, yeah, I don't even like. I can't say that these are benefits because I have a couple of things that are listed in both benefit and con side. One of the interesting things is that because when everybody got the freedom to choose their own frameworks, choose their Node versions, then we had this kind of guild meeting where all of the Node people met up and they were discussing about the best practices and what to do, and it just died out because everybody was free to do what they want to do. And yeah, like developers like arguing. It's like wrestling with a pig. You do it for a while and then you understand that they enjoy it. So it kind of is obvious that people want to still argue about things, but because there's no right or wrong way, you have the freedom to do it. This exchange of information kind of disappeared. It's not a good thing only, it just shows that there's not too much connecting you with the other developers anymore. You can have completely different approaches to, let's say in Node, some teams might do it with async, async library, the other ones are doing promises. There's no rules in that sense. What we look at is like really generic stuff, like does it match the formatting rules, does it follow the code complexity, what the branch coverage is, but there's no guidelines saying that now you have this new microservice that you're creating and you need to do it exactly with promises, and otherwise, no, it's really bad if you don't do it like this. You can always have the bleeding edge versions of Node. So as soon as the async await came out, I think probably somebody already started using it, not sure. Yeah, as I mentioned, even if we at some point in time think that Node is not really like the best thing to do, we can always switch it out. But getting there, the biggest issue is the cost. And I think when we went on this journey, we kind of never expected how many things are actually involved in getting all of this working seamlessly, and not seamlessly. Well, we are not there yet. It's not seamlessly, but getting it all working in a way that you can actually leverage the benefits. So service discovery in some setups like Kubernetes, you will get it out of the box. We didn't take that approach, so we needed to build stuff around it, and it's also good because it creates a consistent layer that isolates it from the technology. So we are using Consul, but nobody's calling Consul directly. We have our own libraries that are defined the exact rules how Consul should be used, so in case it doesn't really work or it starts crashing, we can switch it out. So it's just an abstraction layer on top of it. Configuration, like that was one of the, like if you do microservices, you go above like 10, 20 components like microservices. And if you still do configuration management, like with the standard kind of manual, semi-manual, semi-chef approach, then this will all break at some point. So there's different approaches. One of them is like keeping the configuration central and polling it. The other one that we took is actually having basically zero configuration. So everything that that you need to know about, like other service you need to connect to, you can get from service discovery. And this includes the usernames, the credentials, but stuff like how many seconds should I sleep before something happens. We just like don't configure it. We hard code it the way it should be in live. This way is how to override it in dev, of course, if you want to test it. But it sounds like a stupid idea, and I don't know why, but developers really love to write configuration. But in the end, there's not too many cases where it's actually needed. So there's actually no cases so far that I know of. Dockerization, yes, Docker is a nice thing, but at least during the 1.5 years that we've put a lot of effort into making it happen, it's clearly visible that it's not as mature as it potentially could be. Even the latest, I think it was like a month or two ago when we tried to move all of our dev environment finally to Docker. we ended up with some big mess on the networking side where lots of stuff just magically disappeared. In live, it has been working relatively well. Like all of the stateless layer we Dockerize, I wouldn't dare to put the databases in Docker yet. So it's so-so. It's kind of, by now it's pretty reasonable, but like 1.5 years ago when we started, it was, I would say, quite raw. Routing and API gateway. So we looked around, found that probably the best match is using Nginx with, was it called Congo Lua? Sounded scary. And this was only maybe like 30–40% match of what we wanted to do. We created it from scratch. And I think it was like, even right now looking back, we have more things. We have like traffic, we have Fabio, there's different like API gateways that nicely connect with console and route you to the microservices. I think it still was a good idea. Because that's like the core place where all of your information flows through. And even still, like by this time, there's no like really definite standard of how you should do it. Everybody supports something, but it's not really fully featured. Authentication, authorization, session management. I don't think it surprises you that this all needs to be completely rethought if you do things in a microservice world. Monitoring, alerting. So it's so easy if you have this one big elephant and it's in fever, then ops say that, yeah, something is happening, you try to figure out what it is, and it's that. But if you have tons of these tiny services, there's so many dependencies. And the complex thing is to figure out, like, when actually do I need to do something? So if my service is a database, if that database goes down, yes, probably I need to do something. Or operations need to do something. If my service calls another service and that service's database goes down, then what should I do? Yeah, I can't fix it. So you need to go through all of these like failure scenarios, and you really need to design for failure. And this is something that people are not really accustomed to. Yeah. So on-call duty. Yes, if you have the service, then it's basically as having your tiny startup. You are completely responsible, and if you write bad code, you will get woken up in the middle of the night and you need to fix it. And it's a good thing because it drives quality. You don't want to get woken up in the middle of the night. We did have automatic deployments, but they were manually triggered. Manually triggering these 200 or whatever test box deployments is probably, as you can understand, not an option. So the full like continuous integration, continuous deployment cycle is a definite must if you chase this path and go with like as many people as we do. And yeah, tons of tests. So I was mentioning this Microservices IO webpage that lists a lot of these patterns that you might consider. It's like not all of them are necessary to do. Some of them don't like kind of. If you chase one pattern, it doesn't mean you can't do the other one. But just as a reference, I took the like largest picture, and then I went over all of this and thought like, have we done this? Are we planning to do this? Or like, at least did we consider, like, if I went through all of this list, this is how many that I actually checked. So it might seem simple, but once you deal with it for a like significant amount of time, the actual kind of number of different topics that you need to consider is huge. Worth checking out definitely the page. So coming to the cons, yeah, cost obviously, it's huge. The UI testing I mentioned, it becomes really hard to do. Mostly because if you have 15 teams and everybody changes the product underneath you, then at some point all of it will break and then like, nobody knows what's going on. So you need to focus on the microservice tests more. So one of the most kind of unexpected things, but it's in some sense expected, was that information exchange between the teams disappeared. So instead of actually drawing pictures, I think a lot of the effort in the architecture team right now goes to just making people talk about like what they did and how they did it to get the information flow back flowing back, information flowing back again between the teams. Tooling for Docker is kind of, it's there. It's not the best thing. So if you have just like VMs, the amount of information that you can get from the host in the context of APM or like the security that is like security, tracking the security, like what kernel calls are being made and stuff like that. It's way better if you're using just pure VMs. And tons of investment that you need to do in the cross-cutting concern libraries like logging, service discovery. It's quite a lot of work, first of all, but secondly, because you usually just fix your script to a specific version of it, then they always get out of date. So you need to figure out some way how to kind of detect the things that are old and push the people to move to the newer versions. And there's tooling for this in like when you're building client-side code, for example. I mean, like Windows apps or stuff like that. But in the microservice world, I think there's nothing like a dependency tracker and artifact repository that I've seen so far that would be working or would do it for us. And yeah, the funny thing is that keeping exactly 4 instances running was a problem that I think they spent a couple of months solving. That comes with Docker Swarm, but it's like just a funny example. So no UI test. Yep. Well, maybe just like a couple that are really generic, but if you do UI testing, that usually only involves that specific service. A lot more effort needs to be done on the unit testing, component testing, API testing side. Basic smoke testing, of course, needs to be there. Unit tests are a different type of beast. Contract-based testing we looked into. We are still looking into. We haven't, like, in the sense that it hasn't been a huge success in implementing, but it sounds like the right thing to do. So we keep on pushing. We keep on pushing, and I think we will finally come to a point where it will pay off, but it's still far away to get to that area. A good thing is actually that this chicken versus egg problem, that if you think that you take all of the UI tests away, then the quality will drop. No, not really. Like, trust your developers. They are scared, and especially when they get woken up in the middle of the night. So I think none of the new things that we do are using Backbone anymore. Like maybe just like one. Everybody is moving to React and Redux because of the testability. If you have pure functions, it's clearly better to test them. So this, I guess, is outdated. Apparently, they are at 100% right now with the new dashboard code branch coverage. But yeah, this is an old slide. So yeah, everybody is pretty much working in this kind of direction. So they take some bits and pieces from the UI and they just like slowly but steadily move over towards React Redux. So as a conclusion, I don't know, I guess I'm running out of time anyway. Yeah. It's a lot of work. Would I recommend it? So depends. Like, it really depends what are you solving. If you are doing it just because it's cool, then don't. It's not worth the effort. If you have an actual problem that you have a lot of people who are like constantly getting into some merge conflicts, you have tons of dependency management, and you're growing at a really fast pace, then, and you know that it's like, yes, now we have like 20 people, next year we might have 40, 50, yes, go for it. But yeah, before that, I would just like get the thing to work, try to get to the phase where I have this problem. I mean, it solves the problem. Like, the thing that we went out to fix, the problem that we went out to fix, we fixed it. We didn't fix all of it, of course. We still have the big elephant, and we have some ideas what to do about it, but everything is really costly regarding that. So it's not that it's the worst code that you've ever seen, but every single developer that joins, they always have some ideas how to make it better. And this is a good thing in the sense that, yes, it's old. We need to fix it, but the way to take a kind of 1 year off and just go and refactor everything, we don't have time for that. We need to run a business. How to do it? Our biggest kind of hopes right now with event sourcing, the whole event sourcing pattern and that goes with it. Let's try it out. It's going to be interesting. We'll start focusing on it second half of this year, and hopefully I have some new things to share in a year. So, contract-based testing, it clearly itches the scratch that we have, but it's really hard to get it working. I guess we need to try harder. Security, like we did it to solve a problem. We have tons and tons of things to do when it comes to security, like how the containers talk with each other, how they authenticate, like how all of the signing and everything works. There's a lot of work there. As a really like long term, like how to do the dependency mapping. Like let's say I change this logging library, then there would be some system that tracks like which microservices, which other libraries are using this library, and whenever this version gets bumped, then all of these get kind of bumped to the latest version, triggered, they are built, they are tested, all of the unit tests, API tests are run against it. So we could easily take the libraries that we create and constantly keep them up to date. So we wouldn't need to do it manually. Right now it's a manual process. It has its benefits because nothing breaks. But on the other side, like having all of the services running on the latest version, it's a nightmare, like getting to that point. And data management. A good microservice should have its own storage. So there's lots of different tiny storages, how to kind of get it all out per customer, get it all in a different region or like a different data center. All of this still needs to be worked on. And yeah, we are hiring in case you want to come and help us, because it's a lot of things that we still need to do. And that's it. Thanks. Questions and answers.
So, thank you. So now we have a quick question series. So maybe we can pass the second mic.
Or maybe just repeat the questions. That's it.
Yeah.
Or
Okay.
just repeating questions.
I need to come closer anyway. I have an ear infection, so.
How do you decide which things belong to the same service and which things belong to separate services?
Mm-hmm.
Like if you break things out from the big elephant like you had, how do you decide to put it into the service that already exists, or maybe you need to get yet another new service? How do you make that decision?
So
or at which level?
Yeah. So the question is like, how do we decide like what parts belong together when you break it out from, let's say, the large elephant, or if you are creating a new service? I think the answer is that we do our best to align it with like business capabilities. So we haven't really broken too many things out of the elephant yet. There's a couple of things that we have moved out of there, which were relatively easy to do. But when we decide like the team composition, there's always like the Conway's law. So we try to inverse it. So we build the teams around the business capabilities, and we try to share as little as possible between the teams. So it's really common that teams build, let's say, a cool thing that caches everything. So instead of having one common thing running in the middle, every team basically forks it. It's the same way as with Nginx. You don't use one that Nginx originally created. You create duplicates. So microservices quite a lot often involve a lot of duplication. So how we decide this. I guess the gut feeling is the right answer in that sense. But I think if you want to do things from day one, it's like this domain-driven design and things like that, where you try to figure out what needs to belong together and encapsulate together. It will help you if you in the future want to break out into microservices. Hey.
How do you handle security with this environment at Hawk mode almost?
How do we handle security? The quick and short answer is badly. It's like even if you check things like Kubernetes, like how it implements security, it's not there yet. Like at least at the level that it should be. It's I think they did something that works, that solves the problem, and the security thing will come. And this will, as I mentioned, it will be one of the focus, like key areas of focus in the couple of years coming.
In the future, big changes because
I think it needs to improve. It's a mess. And like even the things that Google does, like Kubernetes supports, it's a mess. It should be way better. So we kind of we are scared, but we do it still because it helps us.
they didn't mention as a cons.
Yeah, I think I might have skipped it, but it's definitely one of the big cons. There's like really good things as well, because the images that you are running, like Alpine Linux, which is like nothing. It's so tiny that there's not too many vectors to attack besides your own code. So there's some benefits as well to it. But on the other side, there's also like big gaps that you need to still figure out. Controlling all of the microservice communication is the big gap.
Question back.
So let's say I'm starting a business and I'm planning to write this super cool application that will be used by millions.
Mm-hmm.
Would you advise to start with monolith first or services first?
How sure are you? Like the question is like, when I start writing a new app and it will be used by millions and it's going to be super successful, then would I start with a monolith or would I start with microservices instead? So my question back to you is, how certain are you that this is going to be a huge success?
Let's say I'm getting already investment, $1 million.
You get $1 million.
I have 3 customers, big, let's say big companies, and now it's very promising. An investor says, "Yeah, I'm going to invest," and I have this option. I have a little application running, but now I can either continue with this one, grow and grow functionality, but it's one monolith, and I can scale it horizontally, or should I think, okay, I can right now easily write microservices and spend a lot of time like configuring them together versus like writing the actual functionality.
So what I would say right now is that, well, 1 million is not that much yet, but still, let's say it's 10 million. If you have the possibility to write the monolith, I would still do it, but I would do good architecture within the monolith that enables breaking out later. Meaning if you manage to encapsulate the areas within the monolith, it's way cheaper. When it comes to the effect is when you have too many developers to actually fit on that code base. So the effects of people changing, or the butterfly effect, like you changing things in core, might affect the work of, I don't know, tens and tens of people. That's when it kind of shines. Right now, if I would start my startup, I would still do the monolith.
I would like to add to that, because I guess 2 years ago at DEVCLUB, someone said if you cannot write a monolith in the right way, you will not write microservices in a good way as well. But I had a question. You said like you can scale microservices, all its benefits and so on. At the same time, Pipedrive is in queue mode, so new clients cannot register. It was news like that. So what happened?
That was an April Fool's joke, and I think we've found a fool.
A question there.
I have a question regarding the logging. So if you have several microservices and the request flows probably through several of these, and each microservice is handled by a single team. So how do you handle the logging, or how the team gets access to all the logs and all this kind of stuff?
So the question is about logging. If the requests go through a lot of microservices and there's, it's even worse, there's queues in between, how do you handle the logging, or how do you kind of manage to trace it throughout the system? So we are kind of lucky in the sense right now that we don't have too much of it. As I mentioned, we don't have the full microservice architecture, but it's more like the legacy is in the box and we try to walk around it. We do have some like things implemented, which is called like correlation ID that should be passed along with all of the requests. That is like one of the patterns to do. There's this new distributed tracing standard or something. I can't remember what it was. I was looking into it like more than a month ago. But there's ways to do it, but it means that you need to have some unique identifiers for all of the requests that need to pass throughout all of the system. So whenever it touches your system at first, it needs to get the unique identifier, and you need to always make sure that this gets passed along. And tooling actually slowly but steadily starts supporting it.
Okay. Do you have like a central logging log storage where everybody can check it out?
Yes, we do have a central log storage. So we actually don't even in that sense log to disk. We just like send everything with UDP towards that central point, and this is to avoid the logs taking down the system. We've been there and done that in a couple of places.
So logs taking down the system, you mean like the disk gets full of logs?
Yeah, stuff like that. So we just like send it right now over the network to the centralized log system.
Thank you so much for the questions. Thank you, Kristo, for the great talk. And let's have some snack break and get back here in half an hour, 8:30.
Thank you.